Hello, Ace Trick students. Mr. Meunier again. Sorry to have to make another video, but apparently I made a mistake in the second example yesterday. In my attempt to make a video, I plugged the wrong number in. And thank you. I was alerted by a student, so that tells me you guys are paying attention, and that's always good. Keep me on my toes, just like class. The mistakes in example 2, I just plugged the wrong numbers in. So on example 2, we have triangle ABC, where they give us all three sides. Side A is 6, side B is 8, and side C is 5. With this setup, again, we cannot use Pythagorean theorem or SOHCAHTOA because this is not a right triangle. Nothing indicates that it's a right triangle. So we cannot use the law of sines because I do not have an angle or an opposite side pair. I have side A but not angle A, side B but not angle B, side C but not angle C. Thus, I have to use the law of cosines to find an angle here. I want to be strategic about this. I discussed previously how the law of sines is a very efficient, quick, easy formula to use, but it does not work for an obtuse angle. Inverse sine does not tell you angles in the second quadrant where your obtuse angles lie. Therefore, I want to use the law of cosines, but I want to use it to find the biggest angle. That will help save some headaches later on. And looking at this, angle B is largest angle. B is the largest angle. That means it may be obtuse. Doesn't have to be. You don't have to have an obtuse angle, but it might be. So I'm going to go ahead and find angle B using the law of cosines. And when I go about that, I need to say that B squared equals A squared plus C squared minus 2AC cosine of B. That's going to give me 8 squared equal to 6 squared plus 5 squared minus 2 times 6 times 5 cosine of B. And this is the mistake I made in the previous video. I accidentally plugged I flip-flopped the 8 and the 5. Silly mistake, my fault. So as I work this one out, I get a 64 equals 36 plus 25 minus 60 cosine of B. And 64 equals 36 and 25 is a 61 minus 60 cosine of B. So 3 equals negative 60 cosine of B. Divide the negative 60 over. So negative 3/60 equals the cosine of B. Take the inverse of this. Inverse cosine of negative 3/60 will equal angle B. If I go to my calculator and I take the inverse cosine of negative 3/60, we're going to get about 92.9 degrees, which is the answer that we're looking for. I'll fill in my triangle here. And then from there, we can go ahead and find angle A and C using the law of sines. I have angle B and side B, angle opposite side pair. That means we can always use the law of sines. And also, there's not going to be any issues about a double angle situation or an obtuse angle because no other angle can be obtuse. Only one obtuse angle per triangle. So I'm going to find angle A. I can do the sine of 92.9 over B, 8, equal to the unknown sine A over its opposite side of 6. Move the 6 over. So 6 sine of 92.9 over 8 equals the sine of A. Take the inverse. and go back to my calculator. So 6 sine of 92.9 over 8. Let's see. So we're going to go trig. Inverse sine of 6 times the sine of 92.9 divided by 8. And we get about 48.5 degrees, which is correct. I should have been double checking this last time. And then once I know angle A and angle B, angle C is simply just realizing all angles have to be 180. So 92.9 plus 48.5 plus C is 180. Go to my calculator, 180 minus 92.9 minus 48.5. And we get 38.6, which is what we're shooting for. So thank you for bearing with me on that one. Again, the homework I would like you to try to do is page 537, number 7, 9, 31 to 35 odd. Keep this bookwork until April 6th. I plan on collecting all but then. I would expect to have a couple of quizzes this week later on. If you got any more questions, comments, or concerns, please let me know.